in the far future. No, it's already happening. Many sectors can benefit from 5G. E-health, distance telemedicine, being able to monitor our health and allowing mobility of the patients to reduce also the cost. But basically transport, some of you might also be using Waze application. I think with Google now that drivers can exchange immediately information about imagine knowing exactly traffic or having yourself a driving car, being able to park anytime, how much this money would save, and how much our lives would become easier. It's not only that, we can understand the challenges and the possibilities, but there are also difficulties we have to overcome. We have 28 member states that have to work together with no delays. We have to basically invest in infrastructure that is needed and do all the reforms to overcome the difficulties that might occur. We've already seen that roaming fees. They're already lifted, most of it in 6 months. We take full advantage of being Europeans and being able to travel with no cost as if we are one country with no borders. So this technology is really fascinating. I hope we can be able to take full advantage of it. I have already addressed for more flexibility to the European Commission because there are some national security issues that have to be addressed to be able to move to pan-European single market. So I don't want to take more of your time because there are exciting things also for you to listen to and see the achievements of 5G technology. Congratulations for being able to lead the way with these technologies and being able, through the World Conference, EuCNC, to bring together all the key players and the investors and the legislators and the opinion makers, the Commission, the European Parliament, and also the authorities of Greece. So I'm looking forward to experience your workshop and the results of your work. Thank you so much for having me. Keep being ambitious, and thank you very much.
Next, I would like to invite Mayor Konstantelos, the mayor of this area, which is the EuCNC Athens and Bari area. It's an area that is touristic, but also is one of the most progressive areas in deploying, let's say, digital systems and digital services for the citizens already. So if you're looking for a smart city partner, I think that Mayor Konstantelos is the person to talk to. Good morning, ladies and gentlemen, dear attendees of the EuCNC conference. I would like to welcome you to the Bari EuCNC municipality of the Athenian Riviera. I hope that the next few days will be productive as far as the conference is concerned, and that in your spare time you will be able to enjoy the unique sightseeing environment our city has to offer. It is a great honor for our city to host such a prestigious conference about such an exciting issue. Mobile technology and networking offer us, the public servants, new, innovative tools to improve the day-to-day life of our citizens. It is essential for all of us who are in public office to be constantly kept up to date about all the new technological developments. In the city of Bari EuCNC, we are very serious about this issue, and already we have introduced many new technological innovations in all the sectors of the city's administration. I don't know if we can call our city a smart city yet, but we are very close to that. And we're close to that because it is one of our main strategic pillars. Today I came to this conference with my specialized associate, not only to greet and welcome you, but also in order to gather more information and to learn more about 5G technology, so that we, when the time comes, will be able to seize all the new opportunities it offers with no or little delay. 5G technology will lead us to a hyper-connected society in which mobility will play an even more important role in people's lives. 5G networks will support interactive multimedia, voice, video and video streaming, internet and other broadband services. It will allow our municipalities to be more effective in dealing with daily issues. Today's technological advancements have provided us with software and applications that can assist facing the town's day-to-day needs, but only in the era of 5G technology we will be able to create real smart cities, because only with 5G technology we will be able to provide today's applications with the network capabilities required. We will have access to accurate traffic statistics and real-time presentation of our GPRS tracking systems in mobile devices. The relevant personnel will be able to see with his or her smartphone very quickly, accurately, and with low cost where the truck is, where it is located, and all other relevant information. Other examples include our capability, with the use of this technology, to see thermal images or videos from infrared, high-definition thermal cameras in the summer, minimizing the risks of urban and suburban forest fires. The technology of virtual reality in this connected society will be available to us and will give us the opportunity to present our city's view, monuments and sites to citizens' smartphones all over the world, quicker, cheaper and with more precision. The technology of augmented reality here at this space will give us the municipality staff the information they need in real time wherever they are. Like I mentioned before, access to databases like this exists today, but with 5G technology will be easily accessible, faster and cheaper. The technology of immersive or tactile internet and the haptic technology will enable us to use remote monitoring, remote driving and industrial remote servicing of our clean energy plant, which we plan nowadays to install in our city. Metering, for example, gas, energy, water, secure building light management, environment, for example, pollution, temperature, humidity, noise monitoring, and vehicle traffic control represent prominent examples of services made available to us in a smart city environment on a level that can only be achieved with the use of the 5G technology. A basic requirement for all those services to be enabled is that very low-cost devices with very high battery life will be made available to those using them. We are continuously looking for ways to improve public safety and emergency services we provide. In addition to new capabilities for administration to citizen and citizen to administration communication used for alerting and support. These applications will evolve to include administration to administration communication, emergency prediction, and disaster relief. Furthermore, mobile networks will act as a lifeline in a situation including general emergencies. 5G should be able to provide robust communications in case of natural disasters, such as earthquakes, forest fires, floods, etc. Several types of basic communications, for example, voice, text messaging, data, and picture, are needed by those in a disaster area. Survivors should be also able to signal their location presence so that they can be easily found. Efficient network and user terminal emergency and energy consumptions are critical in emergency cases. Several days of operation should be supported under those technologies. Ladies and gentlemen, future 5G services will require ubiquitous coverage, including both terrestrial and up-on-the-air locations. For example, drones may be used for supervision to minimize high risk. Drones guided by coordinates will automatically supervise the city and provide the city's environmental services of information they need on real time. The use of technology is our stronger ally in order to create cleaner, greener, safer, and more environmental friendly cities through smart cities. Too much edge of the future. Ignoring the tools that it offers us is a luxury that we can no longer afford. Paraphrasing Ella Becker, I say, give us 5G technology and we'll find a way to apply it for common good. Thank you for your attention.
Thank you, Mayor, for giving us this perspective and also for requirements that we need to take into account and satisfy in our work, in our research work. So, the next speaker comes from our main sponsor, Mr. Georgos Monopas. He is the director of the Fixed and Mobile Access Network Department of the Group in Greece. The title of his talk is 5G and IoT Accelerating Digital and Transforming Everything. Mr. Monopas was born in Greece in 1968. He is currently director of the Fixed and Mobile Access Network Department of the Group. He has actively engaged in technologies like NGA, fiber to the pair or whatever, 2G, 3G, 4G, and Wi-Fi deployment. He has been leading many innovative technology projects like GSM, UMTS, LTE, FEMCO, and Wi-Fi. And to put it plainly, Mr. Monopas has been the one that has designed, optimized, and deployed the Cosmote network in Greece. So, Mr. Monopas, the floor is yours.
Good morning, everybody. I would like to welcome you to this interesting conference, and I hope you enjoy your statement in Greek Riviera of 4 V's, not 4 G's, 4 V's. Vula, Varkiza, Val, 5. Okay, so it's similar with 5G. Let's be inspired to this beautiful place. As well, I would like to congratulate Professor Demestikos for this great event and our law professor, Mr. Panatarios, because I believe that the topics, the very sexy topics that we will be analyzed during the conference. I can say that it's my great honor that I participate in this opening. Actually, I don't know if you were about the success story of Cosmote, but I will try to give you some hints. Cosmote is the biggest and greatest mobile operator in Greece and came to the market as a third operator after 5 years existence of our competitors. And in a years' time, we managed to become the first one. And then in 5 years' time, after 2005, we managed to be the biggest mobile operator southeastern Europe, in Balkan area, by having presence in 5 countries. So right now, actually, we operate 3 networks: 2G, 3G, 4G, by using more than 5 bands, and we provide services over mature networks, as you can see from the figures of the geographical and population coverage. We have already built up a network, 4G network, more specifically, that provides more than 80% population coverage, and is already reaching the early KPIs of 2021 in Southeastern Europe, with the projection actually are mentioned that more or less more than 60% of the data traffic will be over east. Let's see actually the trends. The forecast gives us, let's say, hint that up to 2021, more than 50% of the subscription will be already in 5G. And the majority of the subscriptions will be mobile broadband subscriptions. In order to give you, let's say, a hint about our network, I can say that we have started the 3G network in late of 2003, in order to be prepared to provide 3G coverage for the Olympic Games in 2004. So we managed to provide 80% operational coverage after 70s in 2011. We have started the 4G network in late 2012, and in 3-4 years' time, actually, we managed to have more or less more than the coverage that we built up in 7 years with 3G. So the acceleration of the development is a reality, and the development is, the rhythm is 2 times more than with 3G. And I think that it is an explanation for that, because you can see actually the trend of data traffic. In the last year, the data traffic global-wise have been increased 60%. It's amazing, actually, increase. And already, with the usage of the current application techniques, the mobile networks are capable actually to provide several hundred megabits levels. In the last year, actually, we managed to do a demo, live message network of 600 megabits by using current application techniques and 256 cloud. So, the 4G plus, as they call it, is adapting 5G light rates from the time being. And that's why I'm fully convinced that up to 2021, the data traffic will be 12 times higher than the existing one. And the majority of the traffic will be over smartphones, more than 90%. 2G networks, actually, it was a very success story. Because 2G came in order to serve the existing needs of voice communication all over. With the deployment of the 3G, all of us have been trained in the multimedia and basic mobile programs. And then for 4G came in order to provide high performance mobile broadband. But 5G, it's only a booster of mobile broadband? No. 5G will be a revolution, actually. It will be a business enabler, providing new business models, new revenue streams, virtual networks, energy efficiency, security, capacity, and availability. And what are actually the basics of the 5G? 5G promise that will bring high peak rates that were reaching 10 gigabits. Very small latency, less than 1 second. Massive connectivity. Machine to machine device drop out. 10 Mbps machine to machine data. Ultra reliability. Very fancy and fascinating, actually, developments. So the 5G as a network, as a physical network, will host a lot of virtual networks, actually. The networks, logical networks, that will, in each slice of them, will run according to service specifics. And of course, I think that in the 5G that we will see native software-defined networks. But in order all of them to be true, at least in my era, actually, the wrong path, there are some requirements. And the biggest requirement is spectrum. And massive and minimal. So not only the existing spectrum will be used, but new parts, a new area of spectrum should be allocated for mobile business. I think that as a union, actually, as a European Union, we must pay attention to that. Because I think that we should the operators in order to spend their investment by the right way. Because in the past, the operators have been exhausted in order otherwise recognized. I think that the biggest success story for Europe was the 2G networks. 2G networks have been designed mainly by European engineers. But then actually, Europe have lost the living of the network. And I think, and I strongly believe, that the 5G it will be a great opportunity for Europe again, a great opportunity to overcome recession. But in order to do that, as a union, we should simplify the processes, reduce the bureaucracy, and take faster decisions. It's amazing actually that a forecast of the IT market says that in a 6-time period up to 2021, the IoT devices will be 4 times higher. It's amazing. More than 40 billion devices. When the existing mobile phones, they are more or less 8.5 billion. And this is a subscriber base that we created in the last 30 years. So you can see actually the potential that it is millions of Earth that we want to be served. And I think that two major segments would be massive IoTs and critical IoTs like private safety. And the most amazing actually is the growth that we promised about the financial numbers, that for the annual growth for the next 10 years it will be more than 50% to make. And not only in one particular area, but in other areas, and the most important reputation market. So it will be a big requirement to create applications, to develop software, in order to sell it. Internet of Things has a transformational impact on all industries, reshaping business models, value chain, and entire industry configurations. I'm fully convinced that the next industrial revolution will be through 5G and IoT. And definitely, actually, in order to make this true, we should go through vertical point solutions, which are quite expensive, to a more horizontal approach, in order to drive the cost down. And the biggest challenges, actually, which should be addressed in order for this to be true, it is robust connectivity, standardization, privacy and security, and interoperability with existing routers. But we need to wait for the 5G. The needs are there. And I think that telecom industry up to now, they need to pay a lot of attention to massive consumer projects. I will give you an example actually concerning Enel. Enel have created a protocol, the PLC protocol, and have been dominated up to now the smart power metering business by selling more than 300 million devices. So as the 5G came to the States, they have started to discuss it, they find out that there is an opportunity over to serve massive machines, and everybody they are thought that if we have done it from the time being, and I think that the answer is the narrow one by it is. Narrow one by it is based on LTE technology, it's standardized as well, and it's suitable for the farming even of GSM channels. And it is fully compatible with HDMI. So, from my side, I'm very glad actually that I have seen a lot of tier one operators like those development will listen and push the industry and the centralization models in order to accelerate and become a large channels. And I think the community is a power that will come alive. So, it seems, according to the previous issues, that IoTs will become the option business disruptor, even for telecom industry, will transform the telecom sectors, and will be a business enabler in order to provide new operating models. So, from IT connectivity provider, the operator should be service enabler and service IT provider. And let's see some examples that they are coming massive IoT collapse. I think the mayor mentioned about the smart cities that we already, so I will not analyze it very much. But to make homes, through smart thermostats, through smart lighting, smart entertainment systems, wearables, health monitoring, through smart glasses, iPhone camera, industrial internet, through real-time analytics, factory automation, robotics, supply chain efficiency. Better usage of natural resources, like the water. The biggest actually question that most probably as a humanity will face in the next upcoming years, next decades, it will be the overpopulation. Can Earth actually feed all of us in the future? But smart agriculture most probably can give an answer to that. So, let's relax a little bit and enjoy the following video.
Proximity of people, brands, and markets. That's zero distance. Lead your company into the future now.
So you see actually what happens when the latency is so low and you use container system mix. Okay. So starting as a mobile evolution 5G and IT will become definitely a revolutionary enabler. 5G and IT will enable new functionality for people, societies, business and industry. So there is an era which started just now. So enjoy it. Thank you.
So thank you, Director Mopas, for giving us the view of an operator and of Cosmote on the future, the near future. We move to our next speaker, who is Mr. Mario Campolargo, and he will be telling us on the activities run and managed by the European Commission regarding 5G and the network of the future. Mr. Campolargo, as we all know, is the director of Net Futures. He has, before the European Commission, he has been with EIN for 12 years. He is an electrical engineer. He has a master from Imperial. post-graduate management, and also European Studies diploma.
Mrs. Haley, Dr. Constantinos, thank you for joining us today in this opening session. Let me pay my tribute to the distinguished members of the Technical Program Committee, Professor Domesticas and Professor Protonotaris, also for the Steering Committee, Professor Luis Correa Bernard, all the members of the different committees, all the ones that joined today to make the demonstrations outside, invited speakers, and the person here of Edward Lindemann. Let me thank all the invited speakers, all the participants that come sometimes from far away to join us today. So, ladies and gentlemen, it's really a pleasure to be with you today. The motto of this conference, the Town of 5G, I think is particularly appropriate, and I think that the colleagues that just spoke before me gave an impressive idea of the impact of 5G in all our lives. I'd like to start by giving the political broad context in which we are talking here. Mrs. Kaeli already brought this up front, the digital single market building up. And in this context, we have created a momentum of delivery during the year 2016 on the various vectors of this digital single market. Very important things that are to come, like the telecom reform, like the free flow of data, things that are coming in the second part of the year. Also some complementary actions vis-à-vis copyright, for example. But a number of them have been done already, and just an example here, focusing on enhancing the digital economy, in which we have already come up with some strong documents that guide our implementation. One of them is the digitization of European industry, the strategy that will preside to the development of all the technological, all the policy and legal frameworks that will enable the digitization of European industry, including the aspects of support to deployment, including financial support, and the importance of joining public and private funds in this development. In this series of communications that we could find, 5G always appears as a core enabler to this digitization of European industry. And we always highlight the relation between the traditionally associated telecom industry to this notion of verticals that are so important. And my dear colleague Onopoulos, with whom I co-chaired this conference, already alluded to the Internet of Things dimension, calling upon this multiplicity of verticals in which 5G can support us. Obviously, you can't do that in isolation. You have therefore to promote adequate standardization to try to get a global dimension to 5G that is very important to the development of this global economy. Our vision for 5G is very much the one that actually our Dr. Constantinos, the mayor of Bari, has brightly put up. Smart cities, smartization of everything. Something that 5G can enable, but that is at the service of the citizens of Europe. I'm just alluding here to 4 or 5 of the areas that we believe that are particularly important in the support from 5G, and that have been the result of some studies that we have done. But obviously, I could add to all of those areas, smart cities, wearables, you name it, and our colleagues before mentioned that in particular detail. It's therefore not anymore a telecom infrastructure. It's a business infrastructure. It will support all kinds of businesses and societal needs. That is particularly important because if we all believe on that vision, then there are significant implications on the way we address standardization, spectrum, development applications, investments, deployment, etc. So what is our strategy towards 5G? First and above all, think global. Build international consensus, and this does not limit this to one or two of the traditional aspects, but it is to have a common vision, to adopt some coherent address of the standardization and of the spectrum. And that's in this context that Europe has been leading on establishing joint cooperations with different areas in the world, and I'm glad that some of them are represented here in this event. But we need to act in Europe. We need to be committed. We need to demonstrate, and then we need to deploy. And I think that Cosmote's presentation was very good in this respect. But we need to find an European movement that allow us not to be just the ones that research first, not the ones that demo first, but the ones that deploy first. And we know how late Europe has been, for example, in the development of 4G. And always in this context, it is the industry coming together. It is public and private partnerships acting together. It is the new regulatory framework. It is spectrum policies. But it's all of those elements that will make us act first. But obviously, you cannot have this global vision and you cannot act in Europe if we don't develop the underlying research and innovation that underpins the 5G vision. And that's what we are doing through this public-private partnership on 5G. Now let me address very quickly the importance of the international dimension. We need to team up towards this global vision and coordinated efforts with regions of the world that are, as we are, leading on the development of 5G. And this is Korea and Japan and China and Brazil and very near in the future with India. And obviously with our partners in the United States. We don't have joint declarations at this stage, but we have a very coherent and good collaboration for the last few years in related topics, for example, in the domain of experimentation on future internet. I mentioned the international dimension, but as I said, there is no need to develop a global perspective if we don't want to be major actors in contributing to them. And obviously, we can do it by research and innovation, but let me focus today in this audience on the need to act first in Europe, and therefore in the need to get together this momentum of deploying 5G in Europe. Commissioner Oettinger in the Mobile World Congress addressed precisely this need by launching the idea of a 5G action plan. Obviously, this will be very much related to our ability to develop a telecom framework that is pro 5G. And this is related, obviously, to the manifestation of interest of the industrialists to support 5G deployment in Europe. But we are ready to act on the telecom review and to listen to industry through what we expect to be a manifesto on 5G. And we would like, therefore, to come to the Council and to the different institutions at national and European level with an action plan that will favor the identification of a calendar for 5G introduction in Europe. They will address some of the key, the fundamental enablers, prerequisites to develop 5G in Europe. And those are fiber and spectrum. To stimulate the 5G through ecosystems of innovation, bringing together the telecom, sorry to use this word, traditional actors, together with the vertical actors in the various sectors. In promoting, for example, large, but I'm talking here very large European demos on 5G, in making sure that the regulatory framework is fit for 5G and that we act at the level of standardization and industrial policies. This is what we need to consolidate as an action plan for Europe towards 5G. And we both rely on the effort that we, regulators and others, are putting in setting up this new regulatory framework and on the contribution from the industrial perspective. Standardization is very fundamental. I mentioned in my first slide that we published in the context of the digital single market and communication standardization. The priorities for Europe are 5, and out of them, 5G is one of them. And to be fully in line with what my colleagues just presented, IoT is also one of them, cloud is also one of them, cybersecurity is one of them, and obviously global presence data. On the 5G, we would like to foster and support a global standardization. And we know that you guys that are here, working in the projects at European level, at national level, you will be the drivers to make sure that the standardization is in line with this global perspective and fit for purpose. We support obviously the European and the international standardization efforts, and we want to make sure that the standardization is not just locked into the traditional sector active, but is now very much enlarged to bring the vertical sector representatives as our vision requires. The 5G roadmap is a very ambitious one. Very ambitious one. You know this slide, but I would like to make a slight actualization of this slide. And it is that we need to demonstrate in Europe. So, I'm calling upon industry, all of you, to be particularly active in making sure that national, even regional, or European demonstrations, proof of concept, all of them can converge into making sure that Europe aligns with other parts of the world in developing demo at scale of 5G, in particular in domains with verticals such as, for example, connected cars, smart cities, big events, you name it. Spectrum, as I said, is particularly important. But more important than probably all the details that we may have in plenty of slides is to say that Europe cannot miss the opportunity to, in time, design the spectrum availability for 5G that is compatible with our ambitions. And actually that aligns with the acceleration that we see in countries like Korea or United States in making sure that enough spectrum is available for test, demonstration, and the later deployment of 5G. We know the calendars of the international organizations, international conferences. We cannot simply be passive on this process. We have to find ways of testing under special conditions with the most appropriate spectrum to make sure that we are ready to evolve towards the deployment of 5G. In line with our vision, it's very important that we maintain the right balance between the enhanced mobile broadband, the aspects of massive machine-to-machine communication, and the aspects of ultra-reliability and low latency that characterize the vision that we have on 5G. We need to accelerate everything from standardization to deployment, but we cannot compromise on our vision. Because in Europe, as I said from the beginning, 5G is an enabler to the big vision of digitizing the European industry. So research and innovation, yes, a huge effort at national level, at European level. I'm very glad with the developments that I see happening as a result of the first phase of the 5G PPP. I'm sure that I'll be very impressed with the results of the project that will be launched next year as part of the second phase. we have a number of KPIs, very ambitious KPIs for Europe, very ambitious KPIs for the world. We invest in the order of 700 billion. And because this is a public-private partnership, we expect industry to be very, very serious on this investment. The more serious you are, the more comfortable the investment from the public side is. So apart from those technical, if I may say, KPIs, I would like to raise here very clearly that one important element is to solidify this collaboration between private and public. There is a lot of opportunities coming adjacent to the 5G action plan, with finances coming from European investment banks, from the EuCNC package. But all of that is based on the premises that Europe, private and public, is united into delivering the 5G PPP, and in showing very clearly that the 5G PPP is not just an engine for research and innovation, it's actually a leveraging effect for investments on the private sector. Now, we are in the first phase of the projects. We are delivering very good results. What comes next? A second phase that is very much based on integration of radio and networks, and we will see already first demos and trials, and the third phase where we go even deeper on that front with the early introduction of lower frequency bands and later on higher frequency bands for 5G. All of that, all of this is foreseen, is in our plans, is actually work and the progress. But I repeat again, it's very important that we come up with demos that give the reassurance to our citizens and our policymakers that the work that is being done is of importance for our businesses and for our industry. Let me come back to the action plan, because as I said, research, innovation, demo, and deployment. We have been listening to industry, to what they want to do in terms of 5G. We have now a targeted public consultation, and I invite you in the below address to see and to contribute to this consultation. Because out of these contributions, we want to make a communication that will allow us, a policy document that will allow us to establish and to reach the Council and the Parliament with a 5G action plan. And Mrs. Kaili is probably an opportunity also for you to be our most engaged advocate in the European Parliament to sustain this 5G action plan. What we want to do is to listen to the industry, and we expect that on the 7th of July there will be an investor manifesto on 5G. And then we commit to act very swiftly and to put side by side the telecom review reform foreseen for the end of September with the 5G action plan. Two documents that complement each other. One that sets the regulatory framework, pro-investment, pro-protection of the citizens, and on the side we have a 5G action plan that sets the goal very much and the vision for Europe. Let me just say that my directorate is also changing to cope better with the future challenges that we have addressed. And Mr. Onopoulos will be very glad for sure to know that we emphasize also the Internet of Things. So we create a specific unit on Internet of Things. And together with cloud and 5G, we have therefore three pillars for what the Internet today is about. But we want to look into 2025. We want to look how to foster the champions of that era. We want to see what the next generation Internet brings to us. Reason why we create a new unit called Next Generation Internet. That's in this jigsaw puzzle that we would like to be a support to the efforts of the research, of the innovation, of the business communities in Europe. Let me just conclude by saying that for us, 5G is an enabler for a lot of businesses. is new business opportunities. And we want to be a lead region for 5G. We will not act as we are not acting in one single lever. We want to support the aspects of policies, of research, of deployment, of international cooperation. We want to involve verticals in our work together. We want to tackle aspects of standards and spectrum. And we want to see that you guys, the leaders of research in Europe in 5G, can help us on that one. But I want to leave with you the sense of urgency. We are on a race, and only the ones that are ambitious and move fast will have the chances to win this race. We will win. Thank you.
Thank you, Mr. Capolago. So this brings us to our last keynote for today. It will be held by Dr. Edward Tindeman, who is a Qualcomm Fellow and Senior VP at Qualcomm. He is involved in standards and industry organization. He has been instrumental at various standards and technology from CDMA, 4G and also currently 5G. He serves in the board of companies, several of them, and he was the head in London 2015. He has a PhD on MIT on queuing theory. He has a master on Purdue on bandwidth efficient modulation, and also a BSc on Virginia Polytechnic. The floor is yours, Mr. Tiedemann. After the talk, we will have 5 minutes for questions to Mr. Tiedemann or for another time.
Okay, thank you. Could you bring up the slides there? Okay, first, thank you all. It's a pleasure to be here in south of Athens for EuCNC 2016. 3 years ago, I gave a presentation called The Dawn of 5G at the BBC. And at that time, we were asking the question, where will be a 5G? Because most of that time, most of the operators and all that were saying, why do we need 5G? Okay, well, it's very interesting. The theme of this conference has picked up on this dawn of 5G. The slide that I use here as my introduction is the same slide that I use other than the tiny bit is slightly changed. It shows a surfer on the California coast, very similar to where we are out here today at this particular location. But I want to talk about vision, technology, and where we're at here in 5G. So I think everyone has seen, and I must say, oops, there we go. I think everyone is quite aware of the vision of 5G put down in the IMP vision document now called IM2083 by ITU, which basically has these 3 pillars: enhanced mobile broadband, massive machine type communications or IoT, and then ultra reliable low latency communications. I'll be referring to these somewhat later. But what I really want to talk about is sort of a little bit our vision here of what I call 5G. And everybody starts asking me, what's the hook about 5G? Why are we doing it? And I said, well, one of the things is, besides the issue about every 10 years we create a new gene, but it's really to improve upon our underlying core platform. We don't have, to be very straightforward, in this generation, this one real magical thing that everybody talked about, like CDMA or OFDMA or something like that. But what we really have is the ability to integrate all the technology that we've been working on for the past 10 years or so. Actually, it's even more than that. When we started 4G, we had our kickoff workshop of 3GPP in November 2004 in Toronto, Canada. That was pre-smartphone, guys. We've learned a lot. We've brought in a lot of new technologies into 3GPP. We've had to try to sort of fit them into 4G. Not saying that they haven't done a great job. But the point is, this gives us the opportunity to start with that platform and bring everything back together in a much more coherent way and to provide some really other new capabilities. We talk about one of the things I very much think is really going to be important from the operator perspective, for example, is to be able to integrate basically the backhaul, side haul, whatever you want to really call it, front haul, in with the access. So that we can start putting up cell sites around a place like this room, and I don't have to have fiber in every one of those cell sites. I can have fiber occasionally. Okay, this is particularly true with small cell sites. We've gone a long way, for example, since the original LTE and sophistication on advanced receiver technologies and our signal processing technologies and all of that we've been able to do. We've been able to introduce the concepts of direct device-to-device communications. We've been able to introduce, and we're starting to do a lot, and we'll talk about this later, about vehicular communications on the cellular type platform. And then we've really come a long way in antenna technology, and I'll talk a bit more about that later in my presentation. So, but before we get so focused on 5G on the cellular world, we cannot forget that the IEEE 802.11 Wi-Fi folks are also continuing to basically improve Wi-Fi type technology. Right now there's this major project ongoing on 802.11ax, okay, which is the next key generation of Wi-Fi. Version 1.0, which will be the first core version of that, will be pulled together basically in September of this year, with the final probably publication somewhere about a little over 2 years later. We're targeting right now around December 2018 there for that. So that's that one major step that they're doing. I'll talk a little bit about 60 gigahertz technology. Right now we have 802.11ad. They're working on next generation of that, 802.11ay type technology, and that will provide much more importance in that. The other thing that recently happened is they're starting to develop a concept of a special auxiliary radio called a wake-up radio to do exceedingly low power type of wake-ups, so that you don't have to turn the main radio on, okay, and therefore be particularly useful, for example, in the Internet of Things environment, okay, in that. So, we have to maintain that there are multiple technologies that 3GPP is looking at, and for example, discussing how to integrate, for example, Wi-Fi technologies and such. I mean, it does look right now that 802.11 is not going to be proposing a 5G hook technology to the ITU. So it looks like we're going to have one fundamental technology going forward into the ITU process, which is basically the 3GPP type technologies. I'd like to move on here. And I did a little bit of the slide thing, but I think I would like to talk a little bit about video coding technology and audio coding technology and our service technologies going here. And that's one of our people who's been heavily involved with video coding and the next generation, actually, in terms of H.265 and the HEVC codec, and also now trying to really look at what we might call H.266 codec, which would be the next generation video coding. Where we are going on video coding technology. And I think you can see as we go down from MPEG 2 up here, which is sort of this full thing that we've gone down through these things, we are slowly increasing. I mean, if you look at it today, we're probably about a quarter bit rate with HEVC codecs as we were with MPEG 2, and the MPEG 2 is specifically deployed most of our broadcast technologies today. Okay, but it still takes a lot of bit rates because the reality is we're going up in video resolution. Okay, and I'll talk about virtual reality in a second. But the other thing that we should also know is that the data rates we have to be a little bit careful about. So for example, over-the-top content for 4K video, somewhere around, typically they're sending around 15 to 18 megabits per second. But then what they're actually doing is on complex scenes and things like that, they're actually creating some distortion in video so that we keep that peak rate down. And if we're unconstrained, we would probably be up around 35 megabits per second in some of those complex scene areas where they're actually needed. Okay. And for example, the next generation Blu-ray looks like it's going to be looking at the ability of doing about 50 megabits per second peak with that capability. Now, I haven't talked about virtual reality, and there's no consensus yet on what we actually really require for virtual reality in terms of compression, the right job, things like that. But it looks like it's going to be significantly more, in terms of that capabilities. Of course, there's lots of people trying to play around with that right now. I'd like to turn very briefly now to audio coding here. And we have now as sort of our current thing for the MPEG, the MPEG-H audio coding technology. And there's sort of in there three techniques wrapped up. What we call the traditional channel-based technologies going out there. The stereo, 5171, and now with the height capabilities and actually multiple base channels and all of that going on. And also object-based, which is really good for pinpointing an object. It really doesn't work in many other application areas very well. And then the scene-based or higher on the sonics approach, which is basically representing the sound field through that technology. What I've shown down here at the bottom is basically the Musha scores, which are basically a relative score, give you an idea of the bit rate. It doesn't compare quality, it just compares the bit rate required to get a certain level of quality here. And what we're seeing, okay, is that if we look at these independent ones like 7.1 or 7.14 or 5.1, you can see the bit rates, and you need a couple hundred kilobits per second there to get about an 80% Musha score, which is about broadcast quality. But you got to remember, each one of these particular ones is optimized for that particular configuration and that particular speaker configuration. Okay. Very different thing with Niagara or Sonics approach, where you're basically sending the sound field, and then at the receive end, you're actually doing the processing based upon the actual number of speakers that you have present, the locations of those speakers, and other things. And this really does make it a much more richer and allows us to really move into some of the virtual reality environments much more easily with this type of technologies. So I'm going to move off of looking at those areas, and I'm going to talk about spectrum here. Now I'm going to talk a little bit for the next thing, start to move into the radio area of things. Okay, and we've talked, I think about three types of spectrum we really want to address with our 5G systems. The first is our classic licensed spectrum. And now we have unlicensed usage of spectrum. Okay, and the unlicensed spectrum, we have now been pioneering, I'll talk about this in the next slide, with LAA type technology out of 3GPP, which, okay, on that. But I'd like to actually spend a little bit more time on this slide talking about shared spectrum. And this to me is the real thing that's really going to be happening, and it's going to be one of our big challenges going forward. We just can't find nice clear spectrum out there that they're not incumbent stuff. And I'd like to talk a little bit about the 3.5 gigahertz spectrum, as we call it in North America. I'll do most of my reflections here during my thing when I talk about spectrum on North America things to give you a little bit of a different perspective than just the European thing. So we have this thing that's called CBRS, Citizens Broadband Radio Service. not to be confused with the old CD 27 megahertz stuff that was sort of the social phenomenon of the 1970s. It probably led to the popularity of cell phones, Twitter, Facebook, and all of that. Okay, so this spectrum is 150 megahertz. Part of it is being used right now for the U.S. Department of Defense radar systems, primarily along the coast. There are also some fixed satellite service things on the satellite downlink. There's also some point-to-point wireless. The federal government in the U.S. has come up with a relatively complex way of dealing with this. First, relative to the incumbents, there will be a system called SAS, called a Spectrum Access System, which will then basically say, if I want to use the spectrum at this particular location, I will go query the SAS, and the SAS will basically say yes or no. That's a simplistic way of saying it. It's a little more complicated than that. Now, the spectrum itself will have two types of licensees. A licensed spectrum, so there will be about 70 megahertz of licensed spectrum. These are called priority access licenses, that's the official term that they're using there. And then there will be unlicensed users called general authorized access. What makes it even more confusing, that if I'm a licensed user, and I'm not using my spectrum in this particular area, then an unlicensed user can actually come in and use that spectrum. So it's a rather complicated thing. I think it's a tremendous experiment to see if we can make this all in state-tuned lines. But there's a lot of effort going in to work in industry groups and things like that to try to figure out how to make this type of system work. And it's a precursor to, I think, a lot of the things we're going to do. Because practically, if you look at it, there's actually a lot of spectrum practically available in much of the country. There are going to be areas that you can't use. There will be areas that will vary in time when you can't use it. But most of the time, you're going to get a good chunk of spectrum that will be available. 150 megahertz is pretty good. Now, I talked a little about LAA. For those of you who don't know, LAA is the ability to effectively do a supplemental downlink in unlicensed spectrum. Okay, so basically for a cellular operator, they basically can have a licensed anchor in their spectrum, the licensed spectrum is anchor in their spectrum, and then they basically can use some of the unlicensed 5 gigahertz spectrum for supplemental downlink capability. That's what release 13 of 3GPP did. Release 14 will then bring in ELAA, which will bring in the uplink capability. There's been a huge amount of discussion on this, particularly with the Wi-Fi community. Some of this is basically competitive things and also partially legitimate questions and concerns about whether the existing Wi-Fi systems will basically have interference or anything like that. Certainly from Qualcomm's perspective, our sort of initial mantra, and by the way, I should note, for those of you who don't know, many of you think of us as a major cellular provider of chips. We are also, depending upon, I sometimes say the day of the week, but we're either number 1 or number 2 in Wi-Fi, chip provider. And we sell a huge number of Wi-Fi chips, not only those that go with cell phones, but access points essentially all over. So if you pick up access points, very likely you have a Qualcomm. A large fraction of that Qualcomm in them also. But so from our own perspective, our own customer perspective, it's very important for us. And I myself, in my role, I have to keep the cellular side and the Wi-Fi side, not the loggerhead sometimes inside the company. But just to give you that perspective. So the point is, our goal is to make sure that effectively a LAA user or somebody other treats a Wi-Fi access point or Wi-Fi user no worse than another Wi-Fi access user. So I want to move on and talk about that. I've been talking about LAA. There's another thing that's happening out there called multiplier. Multiplier is basically LA standalone. Okay. What does standalone mean in this case? Standalone means is that you don't need to deploy in conjunction with something in the licensed spectrum. It can be just deployed in the unlicensed spectrum, just like a Wi-Fi access point system. Okay. Where is it useful for? Well, I see two uses for this. First use is by potentially independent operators. Okay. But even more, there is a deployment issue in our cyber systems. And this is the venue type of thing, like this hotel. So in some sense, to get good coverage into a hotel like this, effectively all the operators might have to put access points for cells in the hotel. That adds a lot of complexity and cost to the operator. So the concept is that you can use unlicensed spectrum, okay, and then maybe have the venue deploy the cellular technology, okay, in that, and use what we call neutral host, which is basically a gateway. And then that gateway can connect to all the operators. So, for example, just like I get free Wi-Fi in this hotel as I come in, as part of the, the plan and the attraction, I can come in and then be able to connect to the multi-fire plane system that's in this hotel. You get service, and that could be an incentive for the venue to essentially deploy it, i.e. the hotel to deploy the multi-fire technology. To be very straightforward, multi-fire technology is basically LAA technology, but the ability to operate in a standalone environment. There's a multi-fire forum out there that's actually now working on the technology, and we'll have a release out somewhat later this year. I think I could go on without talking a little bit on vehicle-to-vehicle type technologies. It was brought up earlier, and I brought it up a little bit in my introductory remarks also. Quite a few years ago, one of my teams basically helped create what's now called a pan-European e-call. And I'm hoping we get that well deployed out here very soon. And out in all vehicles and things like that. Since then, we've been going on to look at other things. And what we really started to look at inside Qualcomm quite a few years ago was, could we use cellular type technology for the device-to-device communications? At that time, we really sort of dropped looking at it for vehicular communications because we thought that the 802.11p DSRC, dedicated short-range communications, which will very likely be deployed commercially in the United States into the next couple of years, was too entrenched. However, we didn't really think about everything else happening around the world. And so what's actually happened is that we've learned that there's a lot more openness and flexibility around the world, which is really not quite as far advanced in their thinking on communications as we were in the United States. To really take a good hard look at using cellular-based technologies. So what's now happened is 3GPP has a project going on to basically put the technology in, okay, and basically make the modifications of the device-to-device technology to basically get the tiny tighter and DB will yield a large number of massive number of potential vehicles out there. The thing that we wanted to point out was, in this, we have a chance to read the slide, that there's a significant difference in range. This is showing 140 kilometers per hour, basically the ability to detect another vehicle moves from somewhere around to about twice the distance here using the cellular technology. Basically, what really is doing is that we basically have very much more modern, up-to-date platform. 802.11p was basically developed around 15 years ago, okay, and doesn't include the enhancements in technology, plus it was designed with sort of a Wi-Fi type of mentality or perspective in it, which was sort of cheap, not necessarily super performing types of devices. Well, what we've done in the cellular 3GPP arena is really focused on, because the spectrum is costly, deployments are costly, and all this, trying to get performance out of their interface design. So that's basically the difference that's going on, and I'm quite optimistic that certain parts of the world will actually start really may be seriously considering employing cellular-based EUV type technologies. So I'd like to move on now more to the heart of 5G and talk a little bit about waveforms. About 2 years ago, somebody asked me, what's the magic DMA? You know, is it CDMA? Is it OFDMA? It's all kind of QDMA out there. Well, the reality is, we think it's actually a combination of the two. The main modulation we think is basically continuing OFDMA, which serves so well effectively with LTE technologies. It's particularly good as we go up with a large number of antennas and a large number of spatial streams with MIMO, even though MIMO is an overused term these days, because it really means large number of antennas, not actual streams, as it was originally meant to say. But OFDM is a great technology for that. But one of the flaws of OFDM, I shouldn't say it's a flaw, but one of the attributes of it is typically we want to maintain our orthogonality, but that means we need to schedule OFDMA communications. And that scheduling creates delays. Okay. So we've actually been looking at and proposing that we actually have another type of modulation, which is basically what we call RSMA, reverse spread multiple access, which is really, you can think of as CDMA. And this type of modulation allows us to basically transmit any time. Furthermore, it's asynchronous, so I don't need to get synchronization of the device with net infrastructure and timing and things like that. So it's good from a battery consumption perspective. The device can pop up and send a little message quickly. Okay. Okay. So we have RSMA technology there. So I just like to show a layout here of what we look at sort of some of this in terms of our frame structure would look like. Basically, we believe that we have, if you look here at a time interval, it should be scalable. So we have the flexibility of scaling. We have the ability to have blank subframes, which is a key capability of forward compatibility. One of the little mistakes that we had in LTE was sort of things in every time slot, and therefore it made it a little bit hard to add the text capabilities going on. The ability to intermix multicast device-to-device communications as well as basically unicast communications from the cell site to the user or mobile station. I'll say much. And I'm going to quickly skip over the next two slides because I have a few other things I really want to talk about here. I want to talk a little bit about one of the other things that we believe in, which is to basically build a slightly different frame structure, what we call self-contained TDD subframes. Now, one of the issues with LTE right now, particularly the TDD thing, is that I typically want to send a frame of data, and then I want to get an act back from the other side. From my sent from the base station to get the act back from the EV there. The problem is I got to wait till I can schedule basically the UV to transmit, and then I basically take an entire TTI time slot, maybe just to send one bit of fundamental information from the app. So what we really want to do is look at it within the same slot where we actually send data, have a little and turn around the channel and allow just a little bit of transmission by the other side. So in this case, you can sort of see the transmission from at the end. So the overall frame is we basically have a bunch of headers on it, which we use some of the stuff for D2D, mesh relay, or anything we need from the license spectrum. Okay, for protection of that. Then some other control, basic data, and then we turn around and send it back going the other direction. I should talk a little bit about error correcting coding, because this to me seems to be one of the hot areas of discussion with 3GPP right now. Now, we've been using turbo codes as our basic channel correcting coding since basically the 3G days. It's argued that it's time to sort of throw that away and pick up the LEPC codes. What we've done, and you can do that, LEPC codes here. And what we've done and presented through GPT is a huge amount of simulation, so almost everywhere for large blocks, LEPC codes. We're actually proposing multi-edge LEPC codes for significantly better. But they're still under discussion through GPT, still potentially using turbo codes, and also polar codes are clearly under discussion, and then convolutional codes with tail binding. From my perspective, convolutional codes, tail binding are probably really great things still for very small blocks, turbo for most blocks. Maybe there's a location for polar codes in there. I can't say too much negative about polar codes because they were invented by one of my ex-office mates. So I can't say too much negative. Of course, Bob Gallagher did the LEPC codes, and Peter Elias did the convolutional codes, also a family of first PhD advisor, second PhD advisor. So interesting enough, all the important codes that we're talking about all basically invented by students of each other. So, enough said on that. I'm going to skip over this one. I want to talk more about massive MIMO and now as we go into 5G here. We've done a lot of work looking at massive MIMO. I think most people are quite aware that the potential gains you can get by endpointing and all this. I'll show some results. For example, where if I take a 2x4 MIMO system with a 20 megahertz bandwidth, basically I put more bandwidth into it, same data rates, I'm basically going to get a lot more, same data rates. I'm going to get a lot more capacity because I basically have lower modulation, but then when I add more and more antennas, I'm going to get even higher from that. I'm being mindful of that. I want to more move into millimeter wave, and that's becoming a tremendous topic. I want to talk a little bit in this view about what's really happening in North America on millimeter waves. Last Thursday, there was an announcement by the Federal Communications Commission that at their July 14th meeting, they may issue an order and proposed rulemaking on millimeter waves. And here's what the current plans are and thinking will likely be done. They will be allocating 850 megahertz at the 28 gigahertz standard, 27.5 to 28.35, with two 425 megahertz wide blocks. Okay, so two 425 megahertz blocks allocated. The entire band of 37 to 40 gigahertz will be made available. Now, there is some special sharing considerations in the lower part of that. It's called, and so it's called in some ways the 37 gigahertz band and the 39 gigahertz band. Okay, that's going to be there. Now, they will be available for use probably through auctions in a couple of years. But I'm just saying the direction it's going is going to be massively allocating millimeter wave band. The second thing that they have done is to allocate another 7 gigahertz for unlicensed operation. So today we have basically in the millimeter wave band 57 to 64 gigahertz being allowed, primarily to be used by 802.11ad, which will be used by other things. That will be extended up to 71 gigahertz. So everything from 57 to 71 gigahertz will then be available. And this turns me to 802.11ad. A few years ago, Qualcomm introduced 802.11ad technology as a 60 gigahertz technology. You can sort of see the antenna arrangement here. That's very small, 32 antennas on that. That's a module with an RF chip in the background to basically deal with all those 32 things. This shows a phone with the baseband chip in there, and then the RF chip going up there. Practically, we may have to have a second chip in some of these. In reality, the hand blockages are the problem in that. So, I'm going to skip here. I'm going to go on, talk a little bit more. Okay. Go on. I'm not getting the next slide. There we go. Okay, I mentioned hand blocking issues here. I'll skip over that. I'm getting close to the end of my time. What I want to do is talk a little bit about propagation measurements, outdoors, indoors. We've got a huge amount of this. This particular diagram shows us comparison 2.9 gigahertz and 29 gigahertz, same basic test system and all of that. What's very interesting is the additional richness that you see in the reflections coming off of things like light poles due to the smaller wavelengths, which are now reflecting through the diagram. Hit the next slide. I think the battery's going on with something. Or there's something causing trouble. Yeah. Okay, here we're going to do something. We're going to talk about our millimeter test bed, and then I'm going to talk briefly and close about our new announced lower frequency test bed. Millimeter wave test bed that we've been using here, and then I'm going to tell you to turn to the next slide. The millimeter wave test bed basically has a device in UE, which has 4 subarrays, 4 antennas that are mounted basically in effectively the handset. The base station has 128 antenna, 16 by 8 array technology. If you go to the next slide, and there's a video here, and what we're going to show you here is a video of somebody walking around a vacant floor of one of our buildings. The video, if you click down on the lower left, you should pick it up. Okay, here we go. So what we're seeing is the subarrays and the beams here on the UE, showing that we can do the polar capture, things going on. Then the EOD here, and what will happen is there's a dialogue back and forth. It's going to happen between the UE and EOD, showing basically the scanning process is going on. And then we're going to select the best array, and then put 4 antennas on the UE and best array. Then it basically optimizes the weighting as part of the MSC receiver. Okay, then what was going to happen is we're going to have our guys go down and do a handoff here between the two EOD. As it moves down forward, and you can see that. What's interesting here is you're actually going to see the reflection off of tinted windows. This is by the tinted windows, but the problem with millimeter wave is indoor and outdoor propagation. Okay, you have these tinted windows, but they're very reflective still. Okay, in this case. Okay. We have seen that. Can we go to the next slide? And then finally, I just would like to note that somebody asked me about that just yesterday at MWC in Shanghai. We made an announcement of a new platform for the low 6 gigahertz test beds. So we're talking about the 28 gigahertz now, sub 6 gigahertz test bed. We're going to likely see the sub 6, activities going on in China because of Chile. We'll talk more about that tomorrow. Plus Japan, and in the U.S. we're going through this very interesting auction structure. I talked about the 28 gigahertz, I talked about the 3.5, but we're also going through a 600 megahertz what we call a reverse incentive auction. We basically claim spectrum that's used for TV for cellular. And the timing of that actually, we put that into time. We may actually do basically 5 to 600 megahertz. No decisions are made on that, but there's basically going to be a 39-month transition cycle. It's probably available in 5 to 9. I probably said enough. He's telling me I should shut up so you all can have a break. Or maybe a few questions.
Yes, I have tons of questions, but I'm not going to ask them all. I think maybe just two. One is that the RSMA, as you said, that you can think of it like something similar to CDMA, and you can see that spreading into dimension. I would like to know how is it different? What is it's similar to CDMA, but it's not, and what is the difference? If you can say it in a very, concise way. And the second question is about okay, let me choose the second question then. I think very much more important. Yes. The second question is about the multi-fire. Okay. I think we all have the vision and the wish to really provide a wonderful 5G era for everyone. Okay. But the existing industry players also needs to find a sustainable and feasible business model. Okay. So what's your advice to operators in terms of making use of the multi-fire system? The existing operators.
Okay, let me give the answer on the first question about RSMA. It's basically, you can think of it as a different sequence structure, okay, than classic CDMA. Think of it as that. It's not worth getting into here in this kind of thing. But the point is, with RSMA, you can actually overlay the OFDMA, okay, and when you overlay the OFDMA, it's very likely the OFDMA will still be not just another transmission and combine the types of our few techniques. On multi-fire, I think the issue is really a fundamental issue of operator that you're raising is a question really about the operator business model in general. And the reality is the operators, in my view, have competition from Wi-Fi only networks. Multi-fire is really an LTE platform, okay, that is essentially deployable in unlicensed networks. I think, in my opinion, existing operators always will have the advantage because it has much more ubiquitous networks. I mean, we're here with China Mobile, where you got 1.1 million LTE EODs out there. I mean, deploying something equivalent to that is, it's just the financial cost of all of that relationships. Why? It's so deep, it's only a couple companies in the world that have to do that. We look at it as much more or less a competitive threat that we can deal with this in another referring to continued deployment, which is really a problem for a lot of operators today. It's where we're not getting, in many cases, performance of systems, and where, as I said, it'd be advantageous for a teleoperator, small operator, whatever that own network, where they can get full coverage of all the stores and things like that. I thought it was very much.
So this closes the session. Then we grab a quick coffee and we'll proceed to the next one side immediately.
Steps in, 5G also.